Hello, everyone, and welcome to this 19th episode of my publication at a Glance. Today, we have the pleasure to welcome Dr. Inès Jacquet, who completed her PhD at the University of Aix-Marseille and who is currently a PharmD student at the Hospital of Salon-de-Provence. Today, she will share with us results on the discovery of new hits with anti-leishmanial activities. Inès, the floor is yours.
Thank you for this kind introduction, and hello to all our viewers. I will briefly present you part of my recently published article in the European Journal of Medicinal Chemistry. This project focuses on the discovery of new antileishmanial hits in 3-nitroimidazopyridine series, modulated at position 2 using a newly optimized TDAE methodology. So firstly, leishmaniasis. They are a group of diseases caused by the infection of a parasite of the genus Leishmania. The World Health Organization classifies them as neglected tropical diseases. They are endemic in more than 100 countries worldwide and represent around 1 million new cases and 30,000 deaths each year. Current treatments are limited and often present toxicity, high cost, or emerging resistance. Therefore, there is a clear need for new anti-leishmanial drugs. A well-known antiparasitic strategy relies on the bioactivation of nitroaromatic compounds by parasitic nitroreductase. This leads to the formation of toxic species inside the parasites, damaging its DNA. This mechanism of action is used by many drugs, such as metronidazole against a wide variety of protozoa, and by the recently approved fexinidazole for sleeping sickness. However, no approved or clinically studied anti-leishmanial drug use this mechanism. Our team previously identified 3-nitroimidazopyridine derivatives with promising anti-leishmanial properties. These compounds are substituted at position 2, 6, and 8. However, previous in vivo study in a murine model showed a rapid reduction of the nitro group into an amine, resulting in a loss of activity. Therefore, the main objective of this work was to increase the stability of the nitro group to obtain active compounds in vivo. To achieve this, we aim to modulate the position 2 of the scaffold. We used a newly optimized synthetic pathway using TDAE, or tetrakis dimethylaminoethylene, and N-tosyl-penicillamine derivatives. This reaction enabled us to synthesize 11 new compounds bearing an N-tosyl group at position 2 with various substituents on the newly introduced phenyl ring. We then explored position 8 by introducing either a 4-pyridinyl group using Suzuki-Miura cross-coupling or a parachlorphenylthioether group using nucleophilic substitution on aromatics. All compounds were evaluated for cytotoxicity on THP1 cells and for their anti-leishmanial activity on the actinic amastigote form of Leishmania infantum. We found that introducing an N-tosylated chain at position 2 presents an activity as good or better than the previously identified hits. It allows a fine modulation depending on the phenyl ring substituent. The substituent associated with the best activity were bromine and chlorine atom and the cyano group. In contrast, most modification at position 8 led to a strong decrease in anti-leishmanial activity, except for bromine derivatives, which showed the best results. This is our most promising compound. It contains a bromine atom at position 8 and the new N-tosylated chain at position 2, with a chlorine atom at the position 3 of the phenyl ring. It showed no cytotoxicity and submicromolar anti-leishmanial activity on both the axenic and the intramicrophagic amastigote form of Leishmania infantum. To further investigate its behavior, we synthesized its 3-amino analog using iron powder to reduce the nitro group and evaluated it in vitro. Surprisingly, this compound still displayed micromolar anti-leishmanial activity. This suggests the possibility of a nitro-independent mechanism of action, which had not been previously described for this class of compound. If you would like more details, the full study is available in the European Journal of Medicinal Chemistry. Thanks again to the Young MedChem Forum for this opportunity to present my work.
Thanks a lot, Inès, for this very interesting presentation. and to share with us, to remind us the importance of nitro compounds in this type of application. If anyone watching this video wants to participate, is excited about this format, do not hesitate to contact us. You have all the information you need on that slide. Thank you, and see you next time.